Encapsulation is one of the core principles of the object-oriented programming paradigm. And Flutter, like many modern development frameworks, champions this principle, ensuring our apps are modular, maintainable, and less prone to errors. But here's a question. Ever faced a runtime error due to unexpected data formats? Or perhaps you've been stumped by a missing field when fetching data for your app? These are just the tip of the iceberg when it comes to the pitfalls of not using type-safe objects. Stick around because by the end of this video, I'll show you a solution that not only safeguards your app against such issues, but also simplifies your development process. Trust me, you won't look at your data the same way again. The significance of creating an object and converting a remote data into type-safe object is numerous. Data integrity and safety. A type-safe object ensures that your data adheres to the expected structure. This massively reduces the chance of encountering unexpected data or the dreaded null values where you least expect them. Readability and understandable code. When you and your team reviews the code in the future, a clear structure of what the data looks like is invaluable. This clarity can be the difference between smooth development and hours of debugging. Tooling and development efficiency. With type-safe objects, your IDE becomes an even more powerful ally. Auto-completion, error checks, and refactoring become streamlined process, not a course. Robust testing and consistent error handling. Testing your application is a breeze with type-safe objects, ensuring consistent behavior and user experience. Moreover, when data discrepancies occur, you can handle them uniformly, providing a consistent user experience even in unexpected scenarios. So in today's video, I'll guide you on how to harness the power of type-safe objects in Flutter. Given that most apps manage user details safe in databases, we'll delve into creating an AppUser class. This example will provide you with the hands-on understanding, setting a foundation that you can apply across diverse scenarios in your apps. To save time, I have already created this AppUser class ahead of time for you not to get bored watching me typing like a turtle. Now let's delve deep into each component. Let's start with these properties. The properties of a class, often referred to as attributes or fields, define the state or characteristic of an object. In simpler terms, if you consider a class to be a blueprint, the properties are like the specification you'd find in that blueprint. They store essential data about the object and represent the fundamental qualities that make up the object's identity. For our app user, properties like UID, name, and email provide a snapshot of the user's essential data. These are the foundational piece of information that our app might need to interact with or display the user. With this solid understanding of properties and methods, you'll find it much easier to structure, manipulate, and utilize data effectively in any Flutter app you develop. Next in line is the constructor. The constructor of a class is the one responsible for initializing all the fields. Using required ensures that every time we create an AppUser instance, we provide all the necessary fields, making our data representation reliable. You can also assign a default value inside your constructor. This way, when creating an AppUser object, it uses the default value if value is not assigned. So here in our example class, since display name and photo URL are not yet available when user is first created, this shouldn't be required and need to assign an empty string here as its default value. Down here is the copy with method. This is the most common pattern you can see in Flutter, because when mutating or altering an object, you shouldn't be mutating it directly. You should create a new instance of AppUser and modify the fields that you want to modify. And this copy with method is the one being used to create that new copy or instance. Next is this toMap method. toMap method translates our object into map representation. This is crucial for storing the user data in databases like Firestore or sending it to web APIs that require a map or dictionary format. And the opposite of it is this fromMap method. This method helps in converting a map back into an AppUser object. This is essential when retrieving data from database or API. We check if the map is null and provide a default value to ensure data consistency. Down here are these two JSON and fromJSON methods. These methods further enhance data serialization and deserialization. toJSON converts our object to JSON string, making it easier to send over networks or store locally. On the other hand, fromJSON creates an AppUser object from a JSON string. This is particularly handy when working with RESTful APIs or local storage solutions like shared preference. And here, we can see this toString method. Overriding toString method is a good practice as it provides a readable representation of our object, which can be invaluable during debugging or logging. Down here is the equality operator. By overriding the equality operator, we can easily compare two instances of AppUser. This ensures that when you check if two users are the same, it compares their properties rather than just their memory addresses. And lastly, this hash code. When you override the equality operator, it's essential to also override the hash code. It provides a unique identifier for the object, ensuring that objects with the same properties have the same hash code. This is vital when using collections like sets or when storing objects in hash maps. With this structure in place, not only do we ensure that our data is consistent and safe, but we also equip ourselves with tools and make working with this data seamless, be it for storage, manipulation, or debugging. As you build more complex Flutter apps, you'll find these patterns invaluable in managing and working with data effectively. But you might say, oh, that's tedious work to do. Yeah, absolutely it is. But don't worry, because I'm gonna show you how you can generate this automatically with a single click. Since these methods are essential when building a class, someone already created an extension that we can use to generate this automatically for us. So go ahead to your extensions, search for Dart Data Class Generator extension, and install it. After installing, let's create a new class to demonstrate how to use this extension. After defining the class and its properties, we can click one of our properties and click this light bulb here to make the quick fix option appear. And as you can see, we have these autocomplete options provided by the extension. And we can create the methods that we need one by one by clicking these options. Just like that. But if you want to create all the methods at once in just one click, then you can simply choose the Generate Data Class option. So let's go ahead and clear all of this to see how this works. Voila! Everything was created instantly. As simple as that. As we wrap up, it's evident how instrumental type-safe objects are in Flutter. They're not just safety nets. They're catapults propelling your app development to new heights of efficiency and reliability. Thank you so much for tuning in, guys. If this video helped you out, please give it a big thumbs up, share it with your fellow Flutter enthusiasts, and don't forget to hit the subscribe button because this would encourage me to create more valuable content like this.